Okay, here's the last three columns for this for the properties of all these different kinds of functions. So the square root function does have a different domain as well. And if we go over here and take a look at it, it starts at 0 and goes that way. So x is always greater than or equal to 0. And what's the range? Y is an element of the real numbers. Again, this is the parent function such that y is greater than or equal to 0 as well, because it will always be above the x-axis. It has 0 at 0, 0. Y-intercept, x-intercepts, the origin. Interval of increase. Interesting. So this is a good one. Starts at 0 and increases forever beyond that. But it does start at 0, so how would we show that? Including 0 and goes forever. Again, whether this is inclusive or exclusive is actually somewhat debatable, but in this case it totally makes sense to include it. It's a good example of that. And interval of decrease, never. Is it even or odd or neither? In this case, it's certainly neither. You put, if you do f at negative x, that's, I mean, some of those wouldn't make sense under the same circumstances, right? So square root of negative x, you would put negative numbers in, and it would work. So not that that's not a function, it's still a function, but it's very, very different. So nope, nope. And as x goes to infinity, y goes to positive infinity, and x does not go to negative infinity, so that it doesn't have end behavior on the other side. It doesn't go to negative infinity, so you wouldn't call that end behavior. It doesn't go towards 0, it is 0 at 0 and stops. Okay, 2 to the x, take a look at that one. Some similarities in its behavior and some differences. X is an element of the real numbers. X can be anything. Y will always be just greater than 0. It will never equal 0, but it'll always be greater than 0. It does not have an x-intercept. The y-intercept occurs at 0, 1. And this one is always increasing. I'll go and we'll take a look at that in a minute. Here we go. Right, so going from left to right, here we go. It's y's are getting bigger, getting bigger, getting bigger, getting bigger, getting bigger, and they always will. Interval of decrease, nope, never or none. Even or odd or neither. Vertical asymptote, no. Horizontal asymptote, it does have a horizontal asymptote at y equals 0. As x goes to positive infinity, y also goes to positive infinity. As x goes to negative infinity, y goes towards 0 from above. Don't worry about the little plus sign, but that is, we do differentiate if it's from above or below, but we'll worry about that another time. Okay, and sine x. X is an element of the real numbers, and y is an element of the real numbers such that negative 1 is less than or equal to y, which is less than or equal to 1. Zeros, well, so this is tricky because it has an infinite number of zeros, but we'll talk about one cycle of zeros. So at 0, at 180, and then at 360, we do sometimes write this as a formula. So it would be like 180n, where n is any integer. So it would be 180 times 0 is 0, 180 times 1 is 180, 180 times 2 is 360, and any multiple. And then going back the other way, it would work as well. 180 times negative 1 would give me this one back over here. So we do sometimes write it that way, but we're not going to worry about that for now. So we'll just list the first sort of the ones that are in the first cycle. Okay, y-intercept occurs at 0, 0. Interval of increase. Again, this one is very interesting. So from here to here, it's increasing, and then it's decreasing, and then it's increasing. So it repeats over and over. So again, we do have a way that we can write this, but let's just say interval of increase is from negative 90. Okay, so from negative 90 to 90, and then I'll do another one from 270 up to, what's that one going to be? 450 to 90, and from 270 to 450, and so on. And then interval decrease is the opposite ones. So from 90 to 270, and so on and so forth. Now this makes it look a little bit like a point, but that's not a point, right? We're using interval notation there. Even or odd, so it is odd. It is symmetrical if you rotate it around. No asymptotes. And it doesn't really have end behavior as well in the same sense, because it fluctuates. Depends on where you are in the cycle. Okay, and that is the end of that big table of all the properties.